this template, I have already have the header file, the program definition, this oscillation frequency, and oscon. So this oscon, we will learn later. So this oscon is the oscillation frequency, setting the oscillation frequency. And then I have configured the C port that I want to take output. Okay. And now I need to do this configuration. This program is very simple. So I need to do this configuration. So what I have found, I have done the calculation for the PR2, right? So we have done this calculation for PR2 and we have find out PR2 should be 49, right? So we will use this value here. So we will write down to here that my PR2, so PR2 should be equal to 49, right? And along with this, I have used PR2, so I have to use T2 con. And that we have found that would be equal to 0, 4. So I have found from here, right? So we have done the calculation and found that T2 con should be 0, 4. So I will use this one. T2 con should be 0x 0, 4. Okay. So I have configured T2 con. Now we need to set the duty cycle. So I can write down set the duty cycle. Duty cycle, or this is the same as the T on time, setting T on time. So this is related to, so this configuration it is related to set the period of the pulse. So set the period of the pulse, and this one is the on time or the duty cycle. And on time is related to CCP R1 and L, and that should be equal to, what is the value we have found? It is 0x19, right? So we can take a look. CCP, what is the value? So CCP con. So CCP R1L is 19 and CCP1 con is 06. So I will set CCP1 con, right? CON should be equal to OX06. Now, if you do this code that it is done, it will automatically generate these pulse with the required period and the pulse width. So what we will do, we will run this program. First check whether is there any error failed. So that means we have done something wrong. So where is this one? So capture mode, unidentified OSCON. So OSC1C missing. So now it should be fine. Yes. Okay, that's fine. Now we can see this on my Proteus file. And before we show this on Proteus file, I want to show you that we can use another feature of MPLab. And that feature will also allow you to see different signals at different points. So what we will do, we will first go to the debug and select the MPLab simulation. Okay. So from here, select MPLab simulation. Then we will go to the settings, and here we will set this one is 4 megahertz and we want to use this one, trace all, and break on trace buffer full. So we will apply this one and OK. And then we will go to view and use the simulator logic. So here it can show logic analyzer. It will show me the signal that is produced at RC2. So we have to select the channel, and from here we have to go which one is our channel. Our signal will be available in RC2. So I have to select that one and then OK. Now I have selected my channel. Now it
Hang on,
should,
do we go to view the wait, what's
yes.
that view
So
and
we
the
will go to the view and then simulator logic analyzer.
and then select and then
And
type port.
then you have to select from the channel, you have to select which channel you want
Oh,
to
sorry.
see. Okay. And then this is my signal. It looks like nothing, but if you just uh, make it, we'll select a certain. So I don't want to go this way. So I want to select. Let me select only yes. So it looks okay. So I'll try to reduce a bit. How can I reduce it? It's going all the way. So it's not flexible enough. Okay, so this blue line indicates your signal. So you have the frequencies too large. That's why whenever you uh, keep it, it looks like it's nothing but the solid line. But there are signals available. You can see here. Now I can do it. So you can see your signal. So pulse width has been changed. Now you can change this on time and you can do the calculation and change this on time on your signal. Okay. So this is the one way to see your signal on the logic analyzer. And now we can also see the signal on my Proteus. So we can select the Proteus and yes, so now I need to open my design and to see whether I have my design available in that folder. So let me go to that folder where I have done the programming. So MIT, so this is, I've done the program in microcontroller 2 and this is my 11th program. So this is my, so I will disconnect this one. I want to check whether I have RC2 is producing the signal. Okay, so I have configured for RC2 and my oscilloscope. Have you used the oscilloscope before with the Proteus? So this is my oscilloscope and that is connected with RC2 and channel 1. So if I do this, run this program, then we should be able to see here. we have the signal available. Now we need to make, I will turn off all other signals. They have only channel 1, and I have to extend, and I can make it the period. I want to change the time scale. You can see this is the square pulse has been created. So from here you can also measure the time. So you can take the cursor. I'm not sure whether I have shown you before. You can set the cursor, you can measure the time, and that is showing, the measuring time is showing here. So this is the time. Yeah, this is the time. So you can also measure the magnitude. Okay. So this is how to generate the pulses using program. Right? Any question? So what you need to do, the last part, so let me just make this correction also. It looks, so this is the duty cycle. So I will just delete this. So the duty cycle, what is the, or T on time. T on is equal to X is a variable times T O S C duration period. Okay, so this is the equation. So then you can do your configuration. Okay, that's all right. Okay, any question? So that will be our last topic. We don't want to do anything. So you need to do the last lab, and you need to submit all the lab by last week. So that means on by 26th, you need to submit all the labs. I can create a similar folder and share with you so that you can upload. So this is the lab. Now you need to do a bit modification. If you right click, then period will be changing, and if you use the left click, then period will be changing. So pulse width modulation, implement the right click and the left button task. So what is the right button? So if you program right button or the external interrupt button is pressed, the frequency of the pulse width modulation will be increased when left button is pressed. So right button is pressed, its frequency will be changed. That means your period has to be changed. And how it will be changed, that you need to write in your program. All right, so you need to do this program as a lab. All right, any question, guys? Any question? No question. Okay. So